Here there is the last module of EPA 608 Universal Certificate Type 2. It is repairs and safety. Sorry. Problems and repair.
In this module, we will discuss some of the problems related to oil foaming in a system. We will also learn about how the EPA classifies major repairs.
Foam is a substance formed by trapped pockets of gas in a liquid or solid. A bath sponge and the head on a glass of beer are examples of foams. Refrigerant oil is also a substance that foams. Most of the refrigerant oil in an appliance can be found in the compressor. This is where oil foaming is commonly witnessed. Oil foams due to the continuous motion and high pressures it is subjected to in the compressor. Foaming can have a lot of negative effects, including diminishing the lubricating ability of refrigerant oil, oozing out of joints due to high pressure, and causing overheating in the compressor due to its insulation properties. These problems are common in many systems.
Oil foaming in a system can be located in condenser, evaporator, compressor, expansion device. I don't know. Let's check it. Evaporator. Most refrigerant oil can be found in the compressor. So oil foaming, it's
The
compressor.
EPA defines major repairs as any maintenance, service, or repairs that involve the removal of the appliances. Condenser, evaporator, auxiliary heat exchanger coil, or compressor. Apart from these, any other repairs are considered minor repairs. Evaporator or condenser coils should be removed or replaced if they have an irreparable flaw. Examples of irreparable flaws include rust, corrosion, and ruptures that are too big to seal. Evaporator and condenser coils are types of heat exchangers. An auxiliary heat exchanger is a secondary heat exchanger in a refrigerant system. These are generally found in heat pumps and AC systems that cool vast spaces. Damaged compressors are usually replaced, not repaired. Examples of damage necessitating replacement include compressor burnouts, mechanical failure, and refrigerant leaks. We will talk about compressor burnout in more detail.
A major repair under EPA regulation would be replacing the condenser oil, replacing filter dryer, replacing a condenser fan motor, replacing condenser coil. This major repair.
A compressor burnout is a major fault, which is detectable via oil sample. A burnout simply means that the compressor's motor windings have burnt due to a short circuit. Analyzing the properties of a refrigerant oil sample tells us whether the compressor has burnt out. A short circuit in electrical components produces very high voltage and temperatures. These temperatures burn the refrigerant oil, decomposing it. Burnt refrigerant oil develops acidic properties that can cause significant harm to the system. While repairing any system, a technician should follow these steps: isolating the component, evacuating the isolated section, and waiting for a few minutes to see if the pressure rises in the system. We discussed this in depth in the evacuation topic. When changing the compressor of a system with 150 pounds of R410A, for example, the steps to follow are isolating the compressor, evacuating the system to 0 pounds per square inch, 500 microns, and waiting a few minutes. We mentioned earlier that 500 microns is the appropriate evacuation level for a high-pressure system with less than 200 pounds of refrigerant.
We would take an plank if a unit has a compressor burnout and it is considered a, we would take an air sample, oil sample, okay, and it's major repair, correct.
In this module, we discussed some of the problems related to oil foaming in a system. We also understood EPA's classification of major repairs, which is an important part of the EPA Type 2 course.
Okay, let's go to safety. This is the last module. Last module of
In this
this one.
module, we will learn about a few safety practices that need to be kept in mind when dealing with EPA Type 2 appliances. When working with refrigerants, always make sure to wear the proper personal protective equipment, including safety glasses, safety gloves, safety shoes, and safety hats or helmets. ASHRAE Standard 15 talks about the safety of persons and property on or near the premises of refrigeration facilities. For us, the important part to understand is the equipment room requirements. We know by now that refrigerants are toxic, and inhaling them can be life-threatening. When stored indoors, refrigeration equipment should be kept in a separate room. All equipment rooms must have electronic refrigerant detectors and a mechanical ventilation system running around the clock. These systems draw fresh air from outside into the equipment room on one side and exhaust indoor air on the other side of the room using mechanical fans and blowers. It's a little like a kitchen exhaust fan, only much bigger. Equipment room refrigerant detectors are electronic detectors that can sense refrigerant in the air and sound out an alarm. Along with the alarm, these detectors are capable of turning on the ventilation systems to get fresh air into the room. Any traces of refrigerant outside the system indicates a refrigerant leak. Remember, refrigerants are heavier than oxygen and are likely to settle down at the bottom of the room after leaking out of the system. Only ammonia, R717, which is considered lighter than air, will rise to the top in the event of a leak. The leaked R717 will accumulate at the top of the room, so it won't cause suffocation. For an equipment room with R717 refrigerant systems, a refrigerant detector may not be needed. Provided the mechanical ventilation systems are working continuously, any leaked refrigerant will be safely purged out of the room. Since ammonia is a natural refrigerant, there are no prohibitions on its venting.
An equipment room has an appliance that uses R717 under ASHRAE Standard 15, which piece of the equipment is not compulsory in the room. Okay, fire extinguisher, refrigerant detector, mechanical ventilation system, mechanical exhaust fan. It is refrigerant detector is not required. Yeah, this is for ammonia.
We learned that a filter dryer traps air, moisture, and other contaminants from the system's refrigerant. If a system is open for servicing, repair, and maintenance works, outside air and dust particles may enter the system. Although evacuation removes the air from the system, it cannot evacuate the air in the filter dryer. Filter dryers are designed to trap air, so there is no way to evacuate its contents. A good practice is to replace the filter dryer every time the system is open.
Which of the following should be replaced in the system if the system is open for servicing? Filter dryer.
We learned how to use dry nitrogen to check for leaks and evacuate a system. Dry nitrogen tanks are pressurized, so the cylinders require a pressure regulator to keep the pressure at a safe level during charging. A pressure regulator is required to maintain the pressure and flow of the gas. Remember how the sight glass is used to check for signs of moisture inside a system? Ice or dirt may form on the transparent glass at low temperatures. The sight glass should be cleaned periodically using an isopropyl alcohol spray. Isopropyl alcohol is commonly used to de-ice car windshields during winters.
The purpose of isopropyl alcohol is to regulate the pressure during evacuation, to remove air from the filter dryer, to clean ice and dirt of sight glass, to vent the refrigerant. The purpose of isopropyl alcohol. Okay, I don't know this one. I don't know. No, not. We need to correct. Ice can form on the sight glass at low temperature, so it should be cleaned using isopropyl alcohol spray. This when ice formed.
We saw earlier that a hermetic compressor has all the components in a single shell, which is why its motor, when energized, produces a lot of heat. In a system with this type of compressor, the refrigerant is also responsible for cooling the compressor motor. As a safety precaution, a hermetic compressor should never be started if the system has been evacuated to a vacuum. Like we said earlier, no refrigerant remains in the system after a deep vacuum is drawn. As such, the hermetic compressor's motor winding may sustain significant damage due to overheating. A reciprocating compressor compresses the refrigerant in a cylinder. It is very similar to a car engine. A reciprocating compressor compresses refrigerant vapor in a cylinder using a piston. In a way, reciprocating compressors are like automobile engines. The pistons are directly driven through a wrist pin and connecting rod from a crankshaft. Depending on their size, reciprocating compressors may have one or more cylinders. Multiple cylinders may be arranged in line, opposed, or in a V. In each cylinder, reciprocating compressors have both a suction valve and a discharge valve. These valves give the compressor its ability to pump refrigerant vapor against a pressure difference. They are usually located in the head of the cylinder, in passages connected to the high or low pressure side of the system. Let's follow the compression process in a single-cylinder reciprocating compressor during one complete revolution of the crankshaft. Starting with the piston at the top of its stroke, or at top dead center, the piston begins to move downward as the crankshaft rotates. Because both valves are closed, the downward moving piston reduces the pressure in the cylinder. As the pressure in the cylinder falls below the low side pressure in the suction line, the pressure difference opens the suction valve, letting refrigerant vapor flow into the cylinder. The piston continues down and pulls in more vapor until the cylinder is filled with low-pressure vapor at the bottom of its stroke. Once past bottom dead center, the piston begins its upward stroke. The suction valve closes. As up, its base and pressure in the cylinder exceeds the high side pressure in the discharge line. The pressure difference pushes the discharge valve open, letting the compressed vapor flow out of the cylinder. This continues until the piston reaches the top of its stroke and most of the compressed vapor has been expelled into the discharge line. When the piston begins its downward stroke, the discharge valve closes. The complete cycle then repeats during each revolution of the crankshaft. This is the mechanical positive displacement vapor compression cycle using a reciprocating compressor. Please take a moment to complete the following learning activity. To continue, make your selection. This type of compressor should never be started when the discharge service valve is closed. If the valve is closed, it restricts the refrigerant from flowing out of the compressor. In such a situations, the compressed refrigerant will have nowhere to go and will build up pressure in the compressor, leading to damaged components.
When the blank is closed, the reciprocating compressor might get damaged if it's energizer. When the discharge
We
series
saw that the
valve.
work of a relief valve is to protect the system from excessively high pressures. A common example of this might be the pressure cooker, specifically how the cap on top of the cooker lifts to release the pressurized steam inside it. Boilers and compressor systems in the past have reported blasts due to pressures exceeding the maximum pressure limits for the system. A pressure relief valve is, by far, the most important safety component in regards to pressure mitigation. A pressure relief valve must be included in every refrigerating system to ensure safety. Multiple pressure valves should never be installed in series to the system lines. Installing multiple valves is not necessary as all the pressure can be released through a single valve. Furthermore, allowing multiple valves to release pressure simultaneously may lead to the loss of refrigerant fluid.
Pressure relief valve should never be installed horizontally. Oh, it can be horizontally, parallel. Multiple pressure relief valve should never be installed in a series to system lines. It may result in excessive of the fluid
In
due
this
to multiple
module, we
valves
discuss the safety practices that need to be
releasing
kept in
pressure at the
mind when
same time.
dealing with EPA Type 2 appliances. These practices are critical when performing repair and maintenance work in a refrigerant system.
Okay, now we finish both this problems and repair and safety. Okay, let's go to the quiz. Okay, now we have 8 questions. A major repair under EPA regulation would be replacing condenser coil. Yeah. An equipment room has an appliance that uses R717 under ASHRAE standard 15. Which piece of equipment is not compulsory in room? Refrigerant detector. Oil foaming is in a system can be detected in condenser. Pressure relief valve should never be installed in series. The purpose of isopropyl alcohol is to clean and dirt off cycle glass. We would take an plank if unit has a compressor burnout, and it is considered a oil sample and it is a major repair. When the plank is closed, the reciprocating compressor might get damaged if it's energized. When the discharge series valve is closed, which of the following should be replaced if a system is opened for services? We must change the filter dryer all the time. Let's submit our one question. Okay, which question? This one? 7? Oh, I'm 7. Let me check it. Ah, when the dot is, yeah, I selected. Oh, now all questions submit all. 807. There is number 3 is wrong. Oil foaming is a system can be detected in compressor. Ah, sorry, compressor, not condenser, compressor. Okay, so now we finish this type 2. We totally finish it. The next video we will try to finish, sorry, we will try to finish and start and finish type 3. We'll take it one by one. For type 3 we have introduction, we have leak detection, leak repair, refrigerant recovery and evacuation and charging, and repair and safety. This is the last one. We'll take it one by one.